have one, which is you don't like functions beyond 4 to 6 lines. Like that's your kind of smell. How did you arrive to that? Because I have a few questions on this. So how did you get there?
So first of all, on the line width side, I don't set that at 80. I set it at 120. I did a statistical analysis on that and found that if you go beyond 120, you're outside of the vast majority of programs ever written.
Yeah. Again, mine is completely irrational. So I'm not saying that you have to have rationality described. This is just my feeling.
It's punch card width, so that's rational. 80 columns. And we've been living with that for 50, 60, 70 years now.
Yeah.
Function width, function height, right? The number of lines in a function. I don't really have a limit there. I have said a number of times that I like 4 or 5 or 6. I think that's a good size for a function. If I ever get a function that's 10 lines long, it's not like I'm going to throw it out. It's like, oh, it's 10 lines long. I wonder why. And then I continue on. I like them to be small. And the reason I like them to be small is that if a function does more than one thing and I can pull the two things apart and give them individual names, I find that to be more readable. That's the bottom line. That's the only reason.
Would the inverse, could you say this kind of an inverse, which is the more functions you have to go through to understand what is happening, also the more contextual overhead you have to have? Because I can imagine if I had to have 20 lines on screen that kind of describes a few step process, I can kind of keep that in my head because I don't even have to use an LSP. I don't have to use anything to jump to these definitions. They're just right there in my head. But if you're always splitting these functions up, it can also be difficult to be like, okay, what does this function do? Okay, well, this function's broken into 2 more functions. What do those 2 functions do? Okay, now I understand those 2. Let's undo that one. Let's undo that one. Let's go to the next one. Okay, now we got to go. You kind of effectively build a tree in your head of what is happening. How do you prevent that type of explosion with that type of rule?
So I don't prevent that type of explosion. If that happens to me, there's a single keystroke which will just pop those functions back in, right? The inline refactoring. So in IntelliJ, I can just go, Control Alt N, Control Alt N, Control Alt N, and it puts that whole function back together, and I can read it. So if I find myself in that situation, then it's easy for me to undo it. I also then realize that I had partitioned it incorrectly. Because if I find myself in that situation, it's because I did not put those functions apart correctly. I did not give them the right names. So that's a test for me, right? I can undo it and then redo it in a different way that maybe flows a little better. The fear that you will drown underneath a sea of little tiny functions is not a very good fear. What you want to do is state what each function does, give it a nice name so that when you see a function and you read it, you understand what it's doing without having to read the next function down. If you can get that goal, if you can get it so that you can read a function and not have to understand the next 3 functions down, you've gained a big leg up on the problem of understanding what a system does.
Yeah, I feel like that's true if mutation is low. In the sense that if you have a complex enough problem, right? Like if you write, let's just say any new modern UI framework and you're in the driver's seat and you have to sit down there and you have to do the actual writing of the framework, right? That would be understanding what a function does simply by its name could become excessively difficult. If you've ever read through any of the source codes, anything like that, even though you can kind of understand it, you kind of have to read the code to first really understand what these names mean. And so that's always been kind of one of my problems because what I personally find happen is that I have a lot of these smaller functions and you have a lot of this, and then you go to code review. And code review is really where I think a lot of these weaknesses kind of show up because I can't look at the code without clicking around, hopping to different files, hopping to different locations, trying to gain it in my head because it's like the code was written to be LSP navigatable, but not reviewable, if that makes sense.
Yeah, I understand. I understand the fear, and I understand the experience. I've experienced that as well. You get badly partitioned code, and you're leaping all over the place, and you don't know where anything is, and you can't keep anything in your head because you're constantly going here and you're constantly going there. But that is a smell. That's a symptom. That doesn't follow from the process of breaking things down into well-structured bits and giving them nice names. You can break things down into little bits and give them nice names without forcing that jumping around, and that's part of the discipline of clean code. You don't want to create those nests of leaping around.
Okay.
If you've looked in the book, you've seen that I like to order the functions in the order that they were called. So inside of a class, I will say, well, here's the main function, and then below that are the ones that guy called, and below those are the ones that guy called, so that you can read down in a single scan and stop at the point where you say, oh, I think I understand everything. I don't need to read the rest.
I don't get that last part. That sounds very difficult. But I
difficult? Yes.
Yes. That's why I'm just like, man, I don't know if I could do that. I generally have a slightly different ordering, but I'll grant that to you. I put the most complicated usually at the bottom, the least complicated at the top, just because the least complicated are easy to kind of zip through, whereas the most complicated tends to be very meaty and slow rolling. Okay. I just wanted to get that out because I always have a hard time kind of reconciling how those work and how they work in principle. What it really sounds like to me is that what you're trying to say is that you need the program for 20 years, shoot yourself in the foot a lot of times, and then a lot of these things make more sense. Because, I mean, I'm not trying to put words in your mouth, but that's generally the advice I tend to give, which is that you have to shoot yourself in the foot 100 times before you realize how you've shot yourself in the foot, and then you don't shoot yourself in the foot as often.
The way I like to say it is that I like to be polite to the next person coming. Right. So any kind of code that forces someone to puzzle it out or leap around is rude. It's rude code. And I don't like my code to be rude. I want it to be polite.
Do you think that isn't some level of code you have to jump around, you have to puzzle it out? Because I'm not sure if names can always convey the context, because often the difficulty isn't, in some sense, the names, though naming is very hard. It's in the state change. And the state change can really only be discovered by not just what the function's name is, but by understanding why the state changes and how that affects the next said calls. Isn't there always going to be some level of sorry, I mean, that's why we both agree on the low comment thing. I think comments are largely useless.
Between accidental and essential complexity. There's an essential complexity you cannot get rid of. Then there's a bunch of accidental complexity that programmers add to it that they didn't have to. And my goal is to reduce the accidental complexity to as close to zero as you can get it.
Okay. I like to ride a nice 100% accidental complexity line. It just feels good. Job security. All